Hi class, welcome back. We're gonna begin 3.1 with this video. This is the new chapter, applications of the derivative. In 3.1, we're gonna specifically talk about increasing and decreasing functions. We're gonna define what does it mean to be an increasing function and what does it mean to be a decreasing function. Moreover, how can we use the calculus to help us define that? So we're gonna use derive a test a form of testing increasing of decreasing function. We're gonna also introduce the terminology of critical numbers and how to find an open interval for which the function is increasing or decreasing, and then use increasing decreasing functions to model and solve real problems. Okay, so let me show you with this example what does it mean to be increasing decreasing. So in example 1, we have a perfect a random abstract graph, and you can see here that in blue or purple you see the behavior of the function. So you see that when we read a function, it is understood and it is assumed that we read a function from left to right. This is how we read it, right? So we start from the left and we use that perspective from the left to the right, if you want to think about it that way. So if I want to see when the function is increasing, what we're going to do is we're going to start from the left side, and we're going to see what's happening to the function, right, as we start moving from to the right. Well, as x moves to the right, the value of the function is moving up, right? Is moving up, meaning the value of the function is getting higher and higher and higher and higher. So that's what it means to be increasing. So we assume that this graph is coming around 0.5. What we're saying is that between 0 and 0.5, the function is increasing. And you can kind of see that in here, right? In this interval. The interval is the location where the function is increasing or decreasing or is flat. So these are x values, right? So from the value of x equals 0 to the value of x equals 0.5, the function is increasing, right? That's what I'm saying here. If you notice, after that, the function from here to all the way over here, the function starts to decrease, meaning it starts to go down, goes down. If you think about it, if you're in real life, that means you're descending, right? You're descending. And so we're saying from the x value 0.5 to the x value 2, the function is decreasing. We're not saying what are the actual values of the function. We just know it's decreasing, that it's changing, and it's decreasing the value. And then we see here from x equals 2 to x equals 3, the function now is increasing. The value of the function is going up. So we see that interval between 2 and 3, it's increasing. And then it follows that from 3 to 4, the function is constant. It doesn't change, right? It's nor increasing nor decreasing. In other words, it stays the same. That's what's known to be a constant value of the function. So from 3 to 4. And then from there, we see that from 4 all the way to 6, the function continues to increase again, right? From x equals 4 to x equals 6. The function is increasing, and then from x equals 6 to x equals 8, the function starts to decrease, right? Going down. So what we have said here is that we use the x value and we break it down into intervals to determine where the function is increasing, where the function is decreasing, and where the function is constant, right? So if you notice, it's very important for us to recognize the value of x. So if we try to formalize what we just went through this example, we will say that the value of function is increasing is changing, but is increasing on an interval a to b if the values of x, right, they're getting bigger, meaning you're moving from left to right, right, from left to right, because this is smaller than this one, right? You're getting from small to big. So now this is what it's saying is you're going from left to right. That's all it's saying. And when that happens, the values of the function are increasing, right? They're getting bigger. Versus the function f of x is decreasing on an interval from a to b if the values of x, right, still going from left to right, meaning you're still going from small to big, then that would imply that the function is decreasing, meaning it's going from bigger to smaller, right? So the values of the function is changing, but it's changing to decrease, right? So that's what we are saying to be increasing, decreasing. You will find that there is some kind of inconsistency in the way we define the intervals, open versus close. That's something that is very inconsistent in the process. It is moreover how they interpret it in each textbook. So you will see that in the homework. But I'll do my best there to kind of give you guys a hint on how to whether it's going to be open or closed. The proper thing is to always have an open, but it's very tricky sometimes to define it, to have consistency. So anyway, so that's it for increasing, decreasing. What we're gonna move on here is to what does it mean to be a critical number? A critical number is the value of the function where the function is where the derivative of the function is 0. So here you're supposed to have a prime there, so you will have a prime there, and if the critical number of a function f at a value a in the domain, you have a critical number if f prime of a gives you 0 or f prime of a is undefined. A critical point of a function is then going to be the x value with the f of a value, right? So this is an actual f of a. This is your y value. So that's going to be a critical number. What we're going to see here is we have two cases where that happens, and that actually happens whenever your slope is 0, right? That's what this means. And so that happens there, happens here, it happens there, right? It happens here. So those are critical numbers. Also, whenever the derivative is undefined. Video here. Hope you guys find this helpful. Please let me know if you have any questions. Thank you. Bye bye.